So here's a look at part 2 of the question and answer on the 3D printed train set. And I'm going to be printing quite a few cars. My goal is to eventually set up and pull 30 cars with one of my engines, and I think I can do it. So let's get on with the video. So today I'm working on the trucks, and I thought I would share about the springs and the truck itself, the side frame, and how that all goes together. Now, initially I was printing this all at one time on the X1C. However, not everybody has an X1C, so what I've done is I've designed my truck so that I have basically the truck and then the spring that gets inserted. And whenever I print the springs, I print a lot of them. And these are actually a friction fit. So if you set the spring down in, if you look close at the spring, you'll notice there is a top and a bottom. The bottom has a couple of layers that are together, and the top is actually, this coil goes up. So you put the spring in the hole there, and then if you listen, you can hear me pushing that spring down into the pocket. And again, it's a friction fit. I like to just dab a little bit of CA where I'm going to put the spring, and then set the spring down over the top of it. So that one I did without glue, and this one I'm going to do with glue. So, and if your tip clogs, that's not a big deal. Get yourself a toothpick and take the top off your glue, and you will notice that you can just run the glue using the toothpick, and you don't need a lot. You can see I'm just basically spreading this out, and that's plenty of glue right there. So I'll stick that back in my tip, and I will set this one in here, going in, and then this one. So basically I'm just going to push it down in that bed of CA just like that, and then I just make sure that they're over to the side, and now that's done. So I was asked about my track and how it goes together. Well, you can see that the connector has a countersunk hole on either side. So if you wanted to screw this down, you could. And then once the connector is put in place, you can see it's not going anywhere until I want it to go, or until I want it to come apart. So the way this goes together is to take the connector and put it on one piece of track, and like that. And then I just raise the other piece of track up. I'm doing this left-handed, in fact. So put it in on one side, push it down on the other side, and you can see that the track is now together. And just so we show that again, we take and slide this under, we put it in one side, like that, and then we bring the other side over. Again, I'm doing this left-handed, but there it is. We got one more over here, so we will raise it up, put it on one side. So we put it in on this side, and then we lift the track up, put it in the hole on one side, and then push it down on the other side, and it's in there. And you can see they're very good. They're not coming apart until I'm ready to take them apart. And they're actually pretty simple to take apart too. So here's more detailed information about my switch. I have three pieces that make up the switch. I have the handle, I have the linkage, which you see floating in here, and then I have the main body, which the main body could be mounted to your table with using three countersunk holes that you can see here. 1, 2, 3. And then the switch mechanism is nothing more than the linkage bending this piece of 0.05 millimeter piano wire it is anchored to the leg coming off of the switch machine on this end, and then on the other end it anchors to the floating rail. So basically what I'm doing is bending this wire in the middle, which causes the floating rail to shift its location depending on which way I throw the switch. Now, the good thing about this setup is it'll also allows a train car to come back through the switch in the opposite direction and open the switch rather than derailing whenever it hits this pinched rail here. So that would work out really good if you had a loop. So you had a switch that went into a loop, so there was a loop on this end. So we went out on this rail and we came back on this one. A single line, it just made a loop. Well, you could set it so that it was going to the right, so it would stay on the main line here, make its loop, come back, and then it would open the switch as it passed through. Or you could have it go the opposite direction. You could have it go around the loop going this way, coming back this way, and opening the switch as it passed through. So therefore, there's a couple of different places where this type of switch would be ideal. And of course, I've made all my switches like that. Next question is the windshield and the lights. And yes, they are 3D printed. They're printed out of transparent material, kind of prints like PLA. And I was actually really impressed with it. So I designed the bezels and light fixtures for the front lights, and also the windshield, which you see here, and the side window, which is here. Now also I do have an interior light, and I've actually designed a diffuser as part of my window print, and you see that it comes together here. It literally snaps together because you're forcing the side windows into a pocket, and the LED actually slips in from the back here. You can see that there's a pocket there for the LED to slip into, and then you don't have to, but I've been putting black tape over this. I can run the interior lights and the front headlights, or I can run the side lights, or I can run all the lights. And that's done using 2 channels on the transmitter. So that also allows me to know which train I'm going to be controlling with the transmitter. So here is a look at the other one, and they're both wired the same way. And notice, because I'm using the diffuser, I don't get an abundance of light in the cab. So I don't want a lot of light in there, but I do want enough light that you could tell that there is, in fact, a light in the cab. There's a little more information about the engines. Now, these are the latest version of my engine. They have lights, windows, and these 2 here were the original, my original design. And you see I didn't have the windows nor the light. I did have it so that I could drill out these holes and put in lights if I chose to. Then I got into printing some transparent material, and I had never printed any of that, so I thought, well, okay, so this stuff prints pretty good. Well, I designed another version of my engine, and this time I added the lights as well as the windows and windshield, and that worked out really good. So I have several, well, it looks like there's 3, 6, 8 engines, and only 2 of them do not have lights. All the others have lights. So I probably won't finish these 2 and put power systems in them, but all the others probably will get power systems. And this is a look at the frame, or the chassis, with the gears and wheels ready for motor electronics, and it would be ready to run. Now this box here, this little box with a hole in it. That is where the speaker goes. The next question is about the engine power. Where am I getting power and how much power? Well, I have my engine design set up so that I have two wires running out the back of the engine, and those actually feed into the car behind the engine. And I do not have the load for this particular coal car yet, but I will get that made. But this one here, you can see underneath that coal is a 2-cell 1300 milliamp battery, and this battery will run this car for about, or this train for about an hour and 45 minutes. And I also use a low voltage alarm that I plug to the balance tab, and whenever the battery gets low, then I will get a beep from that and know that I need to change the battery or charge the battery. And you see this here is the battery here is at 778. This battery here is at 753. So this one is just about dead. This one here still has probably 45 minutes of runtime on it. But that's how I go about getting power to the engines, and they're all set up the same way. Here we'll take a closer look at the crane and some of the details. My cranes, they all will pivot. The boom will go up and down. Also, I have a ball and hook, and I'm using TPU that is coiled around the spool, and then I have a pulley up front, and it is functional. However, the cable does not move, or the TPU does not roll up on the spool. You just simply put a little friction on the boom, and then you can adjust and pull the slack out of the TPU, and that's the look I'm looking for. Also, I've added windshields to all the cranes, and that is nothing more than blister pack. The material is cut from a blister pack, and I have a provision in the front that has a slot, and then also in the back underneath the edge there's a slot. So you kink the material at that angle at the top and down near the bottom, and the plastic can be a friction fit, or you can use a little dab of glue and secure it, but it will stay in without being glued. So there's a look at the details I've added to the crane. I also created a hook and added it to the washer that actually holds the truck to the frame, and that works really well. Gives me a place to hook the boom so that it looks more authentic. And I did complete a second pipe car. So I have 2 pipe cars now, loaded with pipe. And I went a little crazy with the cranes and built a few more. Actually, I have 1 more on the printer, so I will have 5 cranes. So let's just say the crane manufacturer has been pretty busy at the factory building cranes. But they turned out really good. So I hope you've enjoyed this little short video of my 3D printed railroad. And again, everything that you see has been 3D printed on the X1C from Bambu Labs. What an awesome printer. And I'm using the Bambu Labs slicer as well. And I'm using Tinkercad to draw the files up. As always, if you have any questions, you can leave a comment, you can send me an email, or give me a phone call, and I'll help you as best I can. Thank you for your time, and enjoy the hobby.